Let's move on to pagination. I guess some people call it pagination. I don't know. I always call it pagination. So that's what I'm going to do for the purpose of this workshop. So basically, we're going to have a list of numbers, each of them representing a different page, at the bottom of our feed of articles. And when the user clicks on one, we want to load a new page of articles. All right. So just to recap, currently we have tags implemented. And when you click on one of the tags, that's our only form of interaction. Clicking on a tag sends a message from view to update through the Elm runtime. Update receives this message, says, oh, I see you have a description of click tag, and you have data is, let's say I clicked on the cars tag, and says, great, I'm going to update that to be our selected tag, which now we can do using our fancy custom type and have it render the appropriate tab accordingly. We also have a type alias for that called type alias message, which says description is a string and data is a string, which we did in the previous exercise. And now we're going to want to introduce a new message for pagination. So when the user clicks on one of these inside of our view, we're going to want to specify another one of these records that's going to say, here is the page that the user clicked on, and here's the description that says they clicked on a page. So we would have description equals clicked page, data equals 2, and we have a problem. So if I click on page 2, that's kind of what I want to happen in that situation, but we said in our message that data is a string. And sure enough, data is a string here. It needs to be a string in order for the functionality we already built to continue working. But here we've said data is an int. Can't be both. It's got to be one or the other. As previously noted, it's really important that message have a consistent type between view and update. That certainly means that different parts of view need to agree on a common format for this message. So one way we could fix this is we could say, I'm just going to add some more fields to message. We're going to have string data, which is a string, and int data, which is an int. And then we're going to be like, okay, for clicked tag, we're going to have string data is cars, like before. Int data is, I don't know, it's not useful here, so maybe -1. And then for clicked page, we'll have string data is not useful, so I guess we'll do empty string. Then int data is 2. But you don't have to think very far into the future to realize this is not going to scale very well. Like every time I add a new type of message to my program, I need to go through and add an additional field to the message, and then every single other message everywhere in my whole program, add another field to that. And most of the time it's going to be nonsense, so I have to pick a nonsense value to use. This is really going to get out of hand. This is really where we've sort of bumped up against the boundary of why using records for message is not really the best choice. So in practice, people don't actually use records for message. I just did that as a way to sort of get us up and running. In contrast, let's think about what happens if we use a custom type for this. Now we can say we have two variants of message. Clicked tag, which holds onto a string, and clicked page, which holds onto an int. This precisely describes every single possibility that we could have for interaction in our program. Either the user clicked a tag, in which case not only do we know that they clicked it, we also know which tag they clicked because we have that string held onto inside the message, or they clicked a page, in which case we have an int representing the page they clicked. If we add more types of interactions, that's fine. We can just keep adding variants, each of which holds exactly the additional contextual information necessary for update to do its job. Great. Now this whole record gets replaced by clicked tag cars, and this whole record gets replaced by clicked page 2. That's it. So now, if this is our new message type, we've gotten rid of the old type alias message, and now we're using a custom type for it. Update can say case message of, clicked tag, in which case we've got the selected tag, and we're going to destructure that in there and give it a name, just as if it were a function argument. And now we can, inside the body of this branch, use the selected tag. Or clicked page, which has the page number, which is an int, and then we can use that in here. And what's especially cool about this is that we don't have to put a default branch. Like before we had to have that else return the model unchanged. That doesn't even come up here. The best part about this is that if we keep adding message types and we ever forget to handle one in update, it won't compile. Elm will say, hey, you introduced a new message type. You're using that, but like you didn't actually write the logic to handle it in update. You need to add a branch to that case expression to handle the possibility that the user does that interaction. Also, if we ever delete one, it'll once again give us an error. Also, if we add one that's redundant with a previous one, we already handled that somewhere else, it'll give us an error. So for many reasons, not just the number of fields that we'd have to put in a record to try and scale that out, Custom types are just they fit the use case of messages like a glove. They're just the absolute best thing we could use to represent this. And it's sort of like a wonderful language feature that Elm has that allows this to work. Little known fact about Redux. If you're familiar with Redux, you may have, this may seem kind of familiar. That's because Redux is actually based on the Elm architecture. The history of Redux is that Dan Abramov was giving a talk at a conference, wanted to implement time travel debugging and hot reloading, which was something that Elm already had at the time. So he looked at Elm and tried to figure out how Elm was able to do that. And the answer was this architecture. But of course, JavaScript does not have custom types. So he came up with an alternative that's based on using JavaScript objects instead. But some of the complaints that people have about Redux don't actually apply to the original Elm because when you have custom types, a lot of those things just don't exist. Okay. To use this to implement our pagination bar down here, we can write a page button on the view side that says I'm going to take an int for the current page number that I'm going to display. It's going to return HTML message. It'll take that page number as an argument, and we'll say instead of onClick and then passing the description record like we did before, now we will just say clicked page, page number. And that will return the message that we want, and then that's what will get sent to update. And then the text is just string.fromInt page number. And now you've successfully connected view and update using our nice custom types to link everything together.